Phoenix Perry. You can find me on Twitter at Phoenix Perry. So I also own a small game studio called Dozen Eyes Games that makes socially relevant games and museum installations. We released a game with U.S. State Department last year to help political refugees adjust to life in the United States. And our current title, which will be out on iOS, we were doing it for Vita, but we changed our mind. And it is called Crystalline. It'll be out fairly soon. It's finished. We're just porting it now. And this was our game for the State Department. It was really quite fun. Let me see. Sorry, it's not my computer here. So then I run an organization called Code Liberation Foundation, which is a 501c3 operating out of New York City. It's an organization that isn't necessarily targeted for developers, even though we teach development. It's targeted for artists, and it's targeted for game artists, creative artists, installation artists, people who are writers and storytellers. And what we try and aim to do is give that group of women the tools they need to make their own games without having to work with a developer. So we've had a lot of really great successful workshops. This is my favorite hackerspace, NYC Resistor, which some of you may know. It was a great workshop I taught people how to make one-button games. So we built the controller and everything in the workshop. That was really fun. We also do game jams. This was the Bossed Up Game Jam, which was quite great. It's based on a Nicki Minaj quote where she talks about being a boss, and it's pretty delightful. Then we also ran 2 years of successful high school classes. And we reached girls between 16 and 18 in magnet science schools in New York City. And we also do these lady jams, which are also really fun. And we also work with a group that, if you're in the room and you have buckets of money, please fund, called Black Girls Code. And we work with them to teach games to their community, to girls between 9 and 15, how to make games. And we have a ton of game development classes. We've taught about 2,000 women in New York City, plus a ton of other women when we've gone to festivals and conferences around the US. And we generally teach everything from C++ to C# to, I've even done a Python class. It's a ridiculous range of stuff. And during this time, I've essentially created an army of game developers that have done amazing things with their careers. One of the co-founders of the organization with me was Nina Freeman, and she is now working on Tacoma. Also, Kat Smalls made Prism Shell, which is a really nice mobile game. Jane Friedhoff made Slam City Oracles, which you could play if you were at Now Play This weekend. And Beglitched was from one of the ladies who came through our ranks. She often makes art for Nina, so a lot of Nina's games were same person, Jenny. So I'm going to talk a little bit about how I engage women in programming, and I'm going to talk about how I do it differently in case any of you are educators in the room. So I engage women in programming using 3 easy steps. 1, you just have to admit the current approach doesn't work, right? And then you have to empower change, which doesn't mean that you use the same platform over and over again. So women majoring in computer science in US universities actually fell 79% between 2000 and 2011. And that number is not dissimilar from yours. And what you need to do here is recognize there's a bias. When that happens, something else is going on. Women just didn't lose the ability to be interested in programming as it became one of the most visible and financially relevant fields on Earth, right? So there was a bias in how it was being taught. And what it turned out to be was CS courses were catering to male interests, right? They were catering to things guys liked. And I decided to reintroduce coding as a way to create things. So this is what your average computer science class looks like, right? Computer Science 101 in C++. That just doesn't look it just doesn't look appealing to me. This is from the Harvey Mudd School, which is now at, I think, 54% women in their development programs or something ridiculous. Creative approaches to problem solving in science and engineering using Python. That one sounds so much more interesting, right? You could cover the same thing in each class, but when you present it like this, it's just boring. So also, this has got to stop. This culture has got to go. So this is a slide I like a lot. Makes me very happy. You have all met this guy. And what happens is this, right? Basically, you get young, enthusiastic girls that come in the room, and there's this bro culture, and it's very intimidating, and they just leave. So my organization has a motto called "No Coder Left Behind." We don't go forward until everybody in the room understands what I'm talking about, or anyone else teaching. And we reintegrated the creative and the technical. We made it about storytelling. We made it about having your own voice and finding your own vision. And we are starting up here on May 4th. This is very exciting. We're at Goldsmiths from 6:30 to 8:30, and there'll be more information on that. You can follow us on Twitter and check out our website for more. And at Code Liberation, and codeliberation.org is us on Twitter. So these are some of the new names you need to know. Becca Rose, Ala Casey, Kona Newhouse. Oh, I have Kona's name twice. And Julie Parisi. Because our last and current members, they're really changing the field. This year alone, they took the Nuovo Award, the Best Student Game Award, did the South by Southwest Harassment Panel, and tons of other things like Technologist of the Year from Brooklyn Magazine. And it's been, or technically Brooklyn, that's right. So it's been a really good year. So now I'm going to talk about my weird projects. So this is the way I approach how I got into machine learning and games, which is a bit different than I think most people are going to have expected. So I think about the 3 E's, as I call them: embodiment, experience, and ecology. So my experience was very similar to a lot of people growing up in the room. I really loved video games, and that was basically all I cared about. And I really, really loved making video games, text-based video games, when they were actually just weird choose-your-own adventures. And that was really awesome to me, and it got me involved in an entire community living on this magical thing without graphics called the internet, which was really great. And I started really getting into programming, and then this crazy thing happened. I ended up with a really bad case of carpal tunnel after working in Silicon Valley for a few years in the mid-90s. And it was because I had just destroyed my body by sitting at things that looked like this. This is a VT100. It is a early Unix terminal, and probably the direction where things are going. Basically, everything was on the cloud, and there's really just no computer here. So I began to not be able to play games for like the first time in my life. I could no longer play games. I could no longer write code. I had to change my approach to everything. And I went from spending, 90 billion hours a week programming to 15 hours a week in therapy for my back and my arms, which were completely destroyed. And I began to discover my range of motion and moving again. And I discovered that motion had its own interaction. And I began to see the body as a technological material. I took everything I knew about play, and I started realizing that my body had all this play within it and all these ways to express itself that were being untapped by user interfaces. So this is going to kind of lead to what I think has been slowly evolving, and I keep going back and forth on the name, but I'm calling it the transformalist approach to games, which takes a lot of the things that the formalists did and moves a little bit beyond it. So the very first thing I built when I was able to start building again was in 2010. And I started 2008 to 2010. It was about a 2-year-long project. And it was a music project. So one of the things that I was able to do when I was all messed up was still play music. And still sing, and it was great. And I had a band called Black Swan. Yes, I know. There you go. Okay. Anyway. And I wanted us to be able to play without having any computers on stage at all. And I ran into some really interesting problems. As a computer scientist, some of you may know how hard it is to get a computer to recognize a gesture, right? Any gesture. It's really hard. And programming in each individual gesture takes a lot of time and energy. And that was time and energy I just did not have. So I decided to look for a new way to train gestures, and I ran across machine learning. So I started using machine learning to train my system to recognize my body and movement and correlate that to my music and my performance and my visuals. And my bandmate invented with Keith McMillan this thing called the K-bow. So if any of you play cello, I recommend checking it out. It is a bow that's like packed full of sensors, and we were routing all the data from our sensors and then my motion into my computer, and then we were processing that using Unity, which it's embarrassing. I have no actual documentation of what it looked like except for a screenshot I took on my phone of the monitor, so, well, life. So this was my kind of guiding force going forward, and that was that the user should never be forced to conform their body to the affordances of an interface. It should go the other way around. So this is classification, which if any of you here have kind of thought about machine learning, you have kind of seen this kind of thing. So if you have like a camera watching a person, and let's just say you're using a hand instead of a whole body, you can have a couple of discrete gestures, and then you can kind of have a training session where you kind of perform each one of these gestures to your system. It looks at each one of the gestures, and then it kind of comes up with the best possible guess of what gesture you're making, right? So this is a really like easy kind of approach. It's called it's using classifiers. So it gives you a discrete, in this case, maybe 1, 2, and 3. Maybe 1 is, if you're a gamer, press play, 2 is jump, and 3 could be smash something, I don't know. But you could come up with all kinds of interesting things to do with that just using classifiers. But classifiers for motion aren't necessarily very interesting because you don't want something to happen just when you're in 3 positions. You want something to continue to happen. So actually what I got really into is neural networks. So neural networks look really scary, but they're just a way of having a whole bunch of weights and a whole bunch of biases to kind of teach your computer how to do the right thing over time. So I would have a bunch of inputs like, a cello being blowed lightly, not a lot of pressure on our pressure sensor, or my arm raised in a camera, like, my hand just up. And then that would be my input layer, right? So I would have all these inputs, and then I would use a neural network to sort of map those inputs to the outputs that I wanted. And the cool thing about neural networks is they let you do this amazing thing called regression, which means instead of getting the first option or the second option or the third option, you can get the first option, the first and a half option, the first 0.96 options. You get the whole range of motion in between those 2 gestures. And sometimes, because there's these weird valleys and like real weird problems with your neural networks, you actually get really weird, beautiful accidents, which was really exciting to me. We just saw a really bad example of something called overfitting using Microsoft's lovely AI application. But in a performative environment, that can be, as an artist, that was kind of interesting, right? Like that is actually something that I think sparked a whole bunch of writing and thinking. So artistically, that can do interesting things. But what it allowed me to do is have this very rich performative space where I could move around this environment, and my bandmate could play her cello very organically, and we would have all the sound and visuals happen. And it was different every time, and that was always really cool. And instead of having like your regular laptop performance where I was just hitting buttons, I had a space to play in. So this was a piece of software that really inspired me. It was the first piece of AI software I ever saw. It was called Auto Illustrator. Does anyone here remember this? Does anyone? It was a magical thing. Came out, I think, like 98 or something. So it basically was cracked out Illustrator. And it had all these lovely auto AI features that are just like kind of basic AI, like, nodalize polygons, instant mute design, generate parity, suck my pixel, which would just make things crazy. And it was really enjoyable. And I actually made better art with this than I think I ever did with like a pen. And I was sad when it died. It died when OS 9 became OS 10. But then this came out a few years ago, and it was exciting. It was called How to Be a Great Artist in Just 10 Seconds. You can Google it. It's a glitch AI application that you can just feed noise into and kind of select things you like over time. So then I started thinking, how can I take all this stuff I know, my love of games and my love of motion, and wrangle that into one specific project. So I made a game called Nightmare Kitty in 2011. Great. In 2011 that allowed me to track emotion using body position. And I won't go into the science behind it, but I tried to embed the game mechanic in the physical form of the game. And that was really fun. And it's actually a fact that emotion can kind of be triggered physiologically as well as psychologically. Those things are linked. And I'm going to skip science. You can talk to me after. But I went on to make performative spaces and games for large groups of people that used controllers that were weird and fun. And you can talk to me about it later. But I want to talk a little bit about this since I only have a few minutes left. So this is my current game. And it has a really nasty ramping problem. Really nasty. It's really easy, and then it gets really hard. And getting users to go from really easy to really hard is really hard because we only know these specific states along the way, right? We maybe have them mapping a timer and et cetera, et cetera. And all of a sudden, this began to look to me like a problem I had seen before, right? So I think I can solve ramping by actually using a neural network and observing, because these things are just generating data, right? I have how few matches my player has made over a time. I have how many traits. This is only stuff I know, but if color is a trait and pattern's a trait and sound's a trait, I know how many traits are on my cards, right? And I can see how my player's performing, and I can train my system and then change the way the game's actually running based on that performance. And I think that will give you really nice game flow if you can find the right tuning. So that's my new project. I work a lot in Unity, so I'm probably going to release it as an add-on at some point, maybe, if I'm real ambitious. If I'm not ambitious, it'll sit on GitHub in some abstract folder called Stuff 10639. But, so cool. That's my projects, and that's enough for me. Oh, great.